This is my next video on Jane. Jane is my software development system. I keep getting asked is how do we put knowledge into Jane? We write software, but how do we make it intelligent? And so this video is hopefully to explain my answer to this question. All software basically worries about content. How do we get the information? Context. What does it mean and what do we do with it? And then finally, no assumptions. We're assuming constantly everything in our software development. Failures in software, and some of them are major. I mean, here's Southwest Airlines today. They're blaming their system being antiquated. Can't handle the load. Rockets blow up, Mars probes, and all of them are, I guarantee you, it's back to assumptions. I assumed it was doing that. I'm assuming it's correct. I'm assuming I can add two numbers, and we can't. We don't know. We're assuming it's going to work. Our whole software development is based upon the assumption that it's going to work from the software development side. And from the user side, they expect the people writing the software know what they're doing. They don't. It's not their fault. It's the fault of our technology. So this is me, Cliff Collins, BS Computer Science. Jane, my system, is an automatic application builder. And my hope is to get rid of programmers. We don't need them. It's really not my job to write your applications. But we want Jane to contain all human knowledge. And then we want it to be explicit knowledge, understood by everyone. This is the hardest thing. I'll get more into this later. And we need to get where nothing will ever be assumed. Do I personally expect to input this knowledge? A qualified yes. And that's what we'll show here in this video. And part of that is we need to have a way for you to input your knowledge, which is Jane must be able to contain all knowledge. Actually, Jane has the applications. She just wants you to qualify what will meet your needs. So Jane's content, knowledge of everything, means all hardware, all packets being sent here and there, all of our hardware information and how to run those, every binary scripting language that exists today or in the future. We need to be programming for the future, actually. Right now, I mean, our programming technology is based upon the 1940s expectations of hardware and software. And we need to look down the road 50 years and say what really, I mean, our hardware is going nuts. We need to be able to take advantage of that. Making Jane smart. What we want is all the commonly and uncommonly known information. And then to give that access to you through a natural language interface. Getting all knowledge entered. Jane is designed to contain all knowledge. That's my job. How do we do that? That's up to me. We want logic to be professionally designed. Most of we have billions of programmers, and unfortunately, how many of them really have the experience to be writing what they write? This comes down to our technology, not anything personal. I'm not saying that they're dumb. It's just our technology does not allow them to do what they really want to do. Our compilers were directed to stay in just what we can do with numbers and so on. And we want all terms and words to be already known and customizable. Customizable, every company has their own terms. I work for a gas transmission pipeline, and I've worked with a lot of companies, but this one, they had a lot of in-house terminology, and internal inspection, or anyway, they had all these initials, and I was going nuts trying to figure out what their terms meant. And I asked everybody, and nobody knew what their own terms were. The engineers knew, but the people out on the floor who hear the terms, but they're not. I ask them, and they don't really know what the terms are. But we need to get Jane to know what those terms are, and then be able to communicate that to the rest of the company. So if anybody doesn't know, Jane will tell them, oh, this means internal inspection with, with x-rays or whatever it is. I mean, there's thousands of test cases. When you're trying to keep the integrity of a national pipeline going, there's a lot of technology behind that. How does Jane attain the world of knowledge? We need to first figure out what kind of knowledge there is. We have compile and runtime knowledge. This is information that the compiler knows. Well, I built this here. I copied this file. I, created this data structure. Who was it and everything else. We have derived knowledge. Okay, what's the highest number of users that make over $10,000 or whatever we want to ask it? We derive that. We go out and we look. We derive that information, and we give that to the application. And then we have lists of person, places, things, and events. These are just facts. These are just simply persons, okay? Bob Hope, who was he? Places, New York City. Things, apples. Events, 1776, what happened? And then facts and logic. So common facts associated with logic, we have units of measurement. This is where we start looking at adding intelligence to Jane. We don't have units of measurement. I was looking at our list of top 50 for the year, and 3 or 4 of them are purely units of measurement. Somebody thought it was Newton force or pounds, and then the Mars probe, $500 million. England was doing it in meters. U.S. thought it was feet. Miscommunication, assumptions. I assume it's feet. No, it's inches, and so we got to get that. But the units of measurements is key to start adding pure intelligence to our base system. Common input forms. Right now, Microsoft wrote 6 common forms. Pick a color. Pick the font and style, prompt for a password and things like that. So we could put in, I would say there's probably 50. We only have 6, and we actually can't use those because they started hiding them on us. And it's extremely difficult to get those. But these should be directly into the compiler. So we just say, look, I want to ask for a password. As simple as that. Math equations. Okay, we need to be able to know all the physics, stresses, thermodynamics. These are simple equations. Electric, temperature. We have thousands of math equations that we know about, and we need to be able to input those into the compiler so that it knows it, so that the user, whoever it is, doesn't have to go drag out their old calculus book to do some of these equations. Street address. We have street addresses, probably the most unique and efficient way. 7710 Janik, where I live. There's only one in the world. So what's that? 10 characters, and everybody can find my house in the world. And so we want to be able to add the knowledge of what a street address is and say, okay, what state is it in, and parcel that out so that it's actually, even though it's written or displayed as a single block of text, it's actually parts. And so we need to be able to do street addresses, phone numbers, date and times. Date and times, we have, I think HP was worried we're trying to come up with a way that we have basically they said we have about 182 date formats basically around the world. For every country has a different date format. Is it month, day, year, or is it year, month, day, whatever it is? We need to put that in as our base knowledge. And somebody says, well, how do we put those in? We just put them in. It's from the compiler side, it's real easy to do this. In probably a week or so of researching what those formats are, we come up with a simple structure that says, here's dates. You got to know when the system will say, okay, what is it? And what language is it in? And so on and so on. Holidays. So if we put in holidays, so every company has different holidays. We need to account for that. We have federal holidays. We have banking holidays. We have German holidays. We have all these other things. We have Julian dates from the first of the year, and so on and so on. Graphics, pictures, text, and emails. These are some of our fundamental pieces of information. We need that in there without any programming. That we can do. That's fairly trivial. Hardware. We need access to all the hardware and actually control it so that we become hardware independent. So our CPU, we control that. We make sure that security, anyway, there's a whole range of things. We need access to all of that. And languages, English, German, Spanish. And so the system will translate. So if you type in your commands or whatever it is you want to type in, or a document or whatever, languages are built in. And we put that in and ensure that this is what I wish I could go and spend a day on all these subjects, but I can't. We'll jump through here quickly. Context-sensitive facts and logic. So we get into accounting terms, APR, AR, and PO. Accounts payable, accounts receivable, purchase order, invoice. Anyway, all these terms, we can put these in, and people would know what they are. Rate calculation, so we have all of our different types of rates, fixed rates, and so on. We can put those into our system so nobody has to go back and calculate these. Crude oil components. This is a fascinating one, and that every oil company has to do this, and basically their oil is judged based on the percentages of all of these chemicals, components of crude oil. And so, and we do that for every industry. So physics has certain things, and so on and so on. And these, how long would it take me to build a oil component? And let's say it's not correct. The whole system is built so that let's say Texaco does something different than Conoco or whatever, all these different oil companies. I've worked with most of them. And we need to solve for math equations so that we can know the units, how they're applied, and do that for math equations. Scheduling and timelines. Just about every system has some sort of scheduling. We put that into the compiler. Same way with timelines and so on. Recipes. This is an interesting one. Food recipes. So we put in a system so that it manages food recipes. But recipes in general really cover a wide range of things. You could say plant operations is a recipe. At 10 o'clock we do this, and we we make steel or whatever it is. There's a recipe for that. So from the software side, to me it's all one thing, but to the rest of the world it's 20 billion different types of recipes. But to the software, it's not. It's just one percentages, when, why, what, process, and descriptions. And so if we think of it as a food recipe, then it becomes pretty obvious. Half cup milk, so on, mix that, but that applies to a whole lot of technologies Whether it's chemistry or building, construction, or whatever, it's still a recipe. I worked for Houston Light and Power and done a lot of electric work too. I was mainly in graphics, so I dealt with a lot of operational procedures and changing out a transformer. There's certain procedures. That, to me, is a recipe. And so this would still apply to operational procedures in car manufacturing. And then a million other. Once we get Jane going, these things will go in very, very quickly. Just the things that I'm naming. I'm not naming all the billions of other things, but if we start here with units of measurement, I guarantee you we'd probably stop 2% of all errors ever generated in our software that we have today. Okay, Jane the keeper. We need explicit naming conventions. These are built in. Explicit means that we can't just say tree. We need to qualify that as an oak tree plant. Difficulty here is that our software now is based upon, and all of this is data structure independent, meaning that all binary structures and all scripting languages will be known by Jane. That's my job. And we use it. We want to get to pretty much a natural language so that if you're running a company doing, let's say, pipeline integrity, and you want to say send crew A out some address to do internal inspection with X-ray or whatever. And so you want to say that. And no limitations. We need to get rid of all these. We need changes to the way we store numbers and dates and everything else so that there's, what do we have? A whole new GPS global positioning system because somebody said, we'll use 10 bits for our date and time, and we ran out of date and times. Now they're going to go to 10 or 12 or whatever it is, and that's only going to be good for 250 years. And anyway, it's just obnoxious. The GPS is going to have 3 versions. It should only have 1. Nobody ever wants to worry about this stuff. So we have to get where we have no limitations. And all of this is handled by Jane. No assumptions back. I'm learning how to do this. I've had about 48 years of experience in software development, worked on every machine. And I'm just now learning how bad I assume everything, and I'm getting away from that. But she wants to handle knowledge in absolute terms. A 3rd grader could understand and be able to read our software without any training. So we want to make all knowledge available. We want access to every data structure out there on our disk. It's our information. We should have access to it. Access to the logic. We don't want to rely on some programmer who doesn't know our business making our decisions for us. Just read the list of all the errors. Relationships, if I say elephant toenail fungus, I hate using that, but you immediately know what could come next. You could say doctors, hospital, cures, medicine. There's only a very few things that are actually related to that you would want to know. We want to represent reality, and the reality is we don't necessarily associate everything to everything, and it's context sensitive. This is very unique to Jane, which is everything is put in context immediately, and so that context then really controls the vocabulary, the logic, and everything else. We want to start slow, We want to be able to manage all information. That's my job. Let's make sure we can do that first. And we need to manage all logic. So that's, if you want a compiler, that's what Jane is. Okay, you want a compiler? Okay, these are the statements, and I think I have right now about 29 different languages: COBOL, Fortran, Assembler, C, C++, C#, Python, R, JavaScript. It's 29 of them. And you could pick and poke any of the statements that any of them use and say, I want C++, declaration statements. Okay, fine. Natural language, you say, create me a new compiler or add your own statements. That's the whole point, is everything is modifiable and testable by itself. And we want to classify numbers, which we want numbers and text and units of measurement, language translators, graphics, pictures, videos, street addresses, and document editor. Let's start here. Start slow. We just put this in. We want to get rid of all of our assumptions. This whole system is to get rid of our assumptions or having to make assumptions. That's why I don't use APIs, because I don't know what they're doing. And we need to get professionals to do the software. So we're not concentrating on your application. We're concentrating on all applications that deal with schedule. Or if you want a browser, an operating system, that's what we concentrate on, not on a particular operating system. All operating systems do the same thing. I tell you the truth, and so thank you for your time. Until next time.